So let's talk about SQL injection. And I want you to understand all the projects in this class are command injection. You're just injecting different languages. First, you're injecting bash shell code, shell commands, then you're injecting Windows shell commands. Eventually, we're going to inject raw binary machine code, but here we're going to inject SQL. The only difference is you're injecting in a different language. Various languages keep having flaws that let you inject code where you were only supposed to be putting in data. They all suffer from that same flaw. So first you have to understand how SQL works. SQL is intended to handle data stored in databases. It is not all-purpose like the Unix command shell. So it handles databases, and the administrator will have the ability to execute arbitrary queries so they can see databases, and you'll see there's one called information schema, which is automatically created by the software and has the basic structure of all the data, and then the one you create that has your company data, which in this case is called widgets. And so you can show tables to see all the tables in the current database. And you see, right now the current database is widgets, so the only table in there is employees. Now, if you can also select constants, and you can concatenate them together, and you can have substrings. So I could select the concatenation of peanut and butter. And this gets data not from the table, it just calculates it from the input. We'll be using that. And you could get substrings. This will be important to us later too. You can pick a few letters out of a string. This is going to start at letter 2 and give me 2 characters, so that's EA. It starts counting at 1. So EA is here. So you can pick out part of a string. Now, but mostly what we want to do is take the data from the tables. Now, if you were the administrator of the database, you could execute. We saw that there was an employees table, so you could just dump all the data from the employees table, and it'll show you it has ID, name, and social security number for 3 people. Now that's fine, but only the administrator can execute a command like that typically. However, you could also select just certain data, like I could select just ID instead of star, and then I get just the IDs. Now if I tried to get a field that doesn't exist, like IID, then I'll get an error message, unknown column. So, okay, now what you can do, if I could put a where clause in, so I could get the person with ID equals 1. This is how you get just one record. You get the name and the ID from this table where this condition is true. So that gets me just this one person's information. All right, you can also have a compound condition. And if you do this, right equals 1 or 2 equals 2, then this is a compound conditional. The first condition is sometimes true. The second condition is always true. So this is going to dump all the data in the table. And that's why if you're able to inject even a little bit of extra text, you can often get away with murder. The command that would have just shown you your data shows you everybody's data. This is how, and before Amazon Cloud, this vulnerability was responsible for like 99% of all the stolen data in the world, because people would make this mistake and you could just dump an entire database, and people did it all the time. Then Amazon brought out Amazon Cloud Buckets, and by default they were world readable, so many companies put their entire data up on the cloud without realizing the whole world could read it, and that became even worse. But anyway, this is a big one. You have just a database server handling anything, and it's pretty easy to make the mistake where people can dump out other people's information instead of their own. So, now the problem is you have to know the name of the columns and the name of the fields to ask for stuff. So how do you find them? Well, you find them from this stuff, the other thing, information schema. So, for example, you can get all the table names in the database here, because the thing that's automatically created, called information schema, always has the same name if you're using the same type of software. So here, I didn't need to know any names at all, but when I run this, I see all these capital automatically created names with internal data it's using, and way at the bottom is the one created by the user. So now I found the name of the table that has company data in it. All the rest of these just have data maintaining the database, but now I found the name of the table. Now, if I want to know the fields in that table, I can select column name from the information schema columns where table name equals employees. So this one I used to find the name of the table that had the company data, and this one I used to find the name of the fields in that table without knowing anything else to start from. And now I know it has ID, name, and SSN. So now I can go and do this. I can select ID from employees. I know the name of the table and the name of the field. So I could select the ID, or I could select the SSN and get, in principle, sensitive data. So that's how SQL works. Now, this is why you never let a customer have a box like this, where they can execute an arbitrary query. What customers have is, now here's a couple flags you can find by using that, just to practice with it. But here's what customers have. You can search for your friend on a social network. So I can search for like Sam to see if there's Sam in the database, and there's no result because there is nobody named Sam. I can't put in, now I don't get to control the entire query. The developer put in all this. The only part of it I control is that. So that's why they think this is safe. But it turns out it's not safe, because I can put in a name that has an apostrophe, like Tip O'Neill. And when I do, I get a SQL syntax error. Now this is the kiss of death. If I can break the syntax with data, that means I have confused it about what part of it was data and what part of it was code. And that should never happen. All the data I put in should just be data. It should never be misunderstood as code. But what happened is, this apostrophe that the customer put in is matching this apostrophe the developer put in. So it's where name equals Tip O, and this is now a command. Now Neil is not a valid command, so you get an error message. All you have to do is put in a more careful injection with an apostrophe and a valid command, and so here's one that will do that. When you run this one, it now says where name equals Sam, which is never true, or 1 equals 1, which is always true. So the compound conditional is always true, and the pound starts a comment, so it eats up the last apostrophe. So this is not a syntax error, it's just a condition that's always true, and instead of getting the one name, I get all the names. All right, so that's a start, but this is the one that you're really going to need to use. Remember, I said if we could put in any select query, you could do almost anything. But all we can put in is a name. This is how you turn a name field into a select field. This completes the first select query. Select all the names where name equals Sam, and there are 0 results. Then you use union. Union lets you add a second select query to the first one, and the second one does select 1, so I get a 1. So now, and I put in all of this. So I can now put in a select from up above. So now, if I want to get a list of all the tables here, I can take this one, and I can put it in here instead of select 1. Now I can do anything I did in the previous one here, and I get all the data. So now I find out there's one table called employees and a table called passwords. Now so I might, now I want to know the columns, so I'll take this one, and I'd like to know what the columns are in that passwords table. So I take this select query out, and I put in that one, and I want passwords. All right, so now there's ID and PW fields in password. So I might want to get those. Now you might think you could do this. That one instead of this one. An ID PW from passwords. This would be good, but you can't have a different number of columns, since the code the developer wrote only selected one field. You only have one column, and you can't union something with 2 columns to something with 1 column. So I can't select 2 things and add it to a table with only one thing. But what I can do is concatenate them. We talked about this before. Concat will take those 2 fields and turn them into one. So now I can do it, and now I get the ID and the password. So these are the kind of tricks you can do, and you'll find a whole series of flags to find here. Now, the pros never do it by hand like this. You do it by this to learn, and then SQL Map is the hacking tool people use. So if you're taking 123, you should be getting used to SQL Map. You'll find some old instructions here from an old project of mine. You can also Google how to use SQL Map. It's a little confusing to use, but anyway, you can totally do all this, and it will automatically do all these steps for you. So there's a couple of versions of projects you can do for extra credit running SQL Map here. And then there's Blind SQL, which is good, clean fun. So here, I'll just reset the server. I do that now and then in case students have been messing it up. So here I got the same thing. I got a name field. So when I search for Bill Gates, it finds Bill Gates. Okay, but this is blind SQL injection, and you can tell because if I do one of these injections here, here's one of those injections carefully designed to dump everything. So this selects name from employees, where name equals X, which is probably never true, or A equals A, which is always true. So this should give me all the names in a database, but it doesn't. Look what it does. It repeats what I put in. So when it works, it repeats what I put in. When it fails, it gives me nothing. I never get any data from the database. So you might think I can't get anything done, but I can. I can get 1 bit of data per query. You have to construct something with a condition that's either true or false. So here I have A equals A, which is true. If I make it A equals B, that's false. And now I get nothing. So if I see nothing here, this condition is false. If I see something here, this condition is true. Now you can play the game 20 questions. 20 questions is an old game where you can ask about something, but all you can ask is a yes or no question. Is it bigger than a bread box? Is it alive? Is it a movie? Is it the name of a person? And it turns out within 20 questions, you can find anything. Because that gives you, 10 questions gives you 1 in 1,000 separation. That's 1 in a million. So the same thing applies here. So if I want to know how long the name of the database is, for example, I can use this. This will look, okay, let's run this one. So first it looks to see if the name equals X, which is never true. Then it asks, is the length of the database equal to 1? And that is not true, so I get no answer. Well, then it must be greater than 1, huh? I could put in greater than 1, and that's true. So is it greater than 5? And it is greater than 5, so you're on the road. I can now find out how big it is, and if you look at the previous ones, you can actually pump out passwords or anything 1 letter at a time. I can use substring to find the first letter of the password, and let's go back to that one. Well, once you find something, like I have a name here. I know there are names like Bill Gates, so here we go. Here's the example of these. So this is the one that's going to look for the letters in Bill Gates' name. So let's run this and then talk about it. So where name equals X, which is never true, union selects name from employees where name is Bill Gates and substring of name 11 equals B. So this is the way you get the first letter of the name, and the first letter of the name is of course B, so it's true. So I get an answer. The first letter of the name is B. If I made the first letter of the name C, that would be false, and I don't get an answer. So you can find out, and by the way, you can also use less than and greater than for letters. So I can say it's less than C, and that means it's before C in the alphabet, and that's true. So you don't need to guess the letters 1 by 1 26 times. You can go less than and greater than, just change the available options by half every time. So you can get a bunch of flags out of here, including to where you're actually getting passwords, complete passwords out of here. It just takes a little patience and bringing queries like this. So that's what I wanted to show you. It's an interesting challenge, and it's good to learn how this works, and this kind of logic is used a lot. There's a whole lot of hacking challenges where you just solve things by brute force by this kind of trick. And what we're doing here, if you keep splitting it in half, that's a very efficient search routine. Anyway, I'm going to stop this video.